All right, hello, welcome to a new problem. Today we're going to do two sum. Number one on LeetCode, pretty iconic one. Let's see if I can solve this right now. So given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. Okay. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, so that's cool. You can return the answer in any order. So just to note, let's keep track of what we're doing. Okay, so for our inputs, we're given an array of integers named nums. So nums, which is int array, and then we're also given integer target, so target int, and the output is two indices, and I'm pretty sure they're in a list. To note that add up to target. And then to note, we're also given that there is exactly one solution in every input. Okay, so I guess for some questions, I would say like, oh yeah, also to note that I forgot that we can't use the same element twice. Okay, so that's very good to note. Let me think. Let me think. Let me think. Okay, so for some questions, I don't really have any questions other than like, because I know if we're given if we're tasked to find a sum of two numbers that equal up to the target, of course our minimum is going to be two. So I'll just ask it again. So what is the min size of nums? And if you scroll down, it's two. Okay, so that's cool. Okay, so um. now that we know the input and output, we ask some questions and take some notes. Let's go over some examples to kind of showcase that I do understand this problem. So example one, let's say that nums is equal to like 1, 2, 3, 4, 5, and we want to get the sum of 6, which indices add up to 6. Or better yet, 5, 6, which add up to 7, right? Which numbers add up to 7? Well, in this case, there's multiple that I can see already, but let's just go through it, right? So we can say like 1 plus 1, that's 2, 1 plus 3, that's like 4, and so on. 1 plus 1, 2, 3, 4, 5, oh, 2, 4, 5, 6. And for the 2, we say 3, 5, 6, 7. So we did find 7. So the indices would be index 1 and index 4. Yeah. So that would be the return value, right? Um, so let's go through another example. I guess like a more easier one to kind of guess. So 1, 2, 3, and then 10, right? And that'll be, if we want the target to be 11, right? So obviously we can go through everything, right? So 1 plus 2, 1 plus 3, 1 plus 10, 2 plus 1, 2 plus 3, 2 plus 10, and so on. Actually, let's make it 13, right? And then we go to 3 plus 1, 3 plus 2, and then 3 plus 10, and that's equal to, um, yeah, and that's equal to 13. Cool. So that's awesome. So we can say the indexes are 2 and 3. All right. And so I do understand this problem, I think, but just solving it, it's kind of mind-boggling as of right now, because there's a part of me that wants to optimize this. Anyways, let's go into some tools we can use to solve this problem. Speaking of optimizing, we can use the hash map. I forgot in which way we could use the hash map. I know that we can use the hash map to kind of see the values, and then maybe I guess we can use the key as a value, and then the value as an index for that value, I guess. Um, so let me think. And then we can also use some if statements. check, and we can use a for loop. And then, yeah, that's pretty much it. We're also going to use, we can use addition or subtraction operations. I'm not sure which one we could do, but those are just some tools we can use, right? Um, so what I want to do is I want to kind of just make a plan, right, of what we can do. So first off, we get user inputs, and then once we get user inputs, we can initialize a hash map, right? So a hash map is equal to empty hash map. And then I want to, hmm, what can I do? Um, I guess what I can do is, since there's exactly one solution, right? I think we can just iterate through all the numbers, right? And then subtract it by whatever, and then see if that's in the hash map, right? Um, See if that number's in the hash map, and so on. Um, and then I'm pretty sure, since like the difference, since like we'll get the difference from every number of the target, even if the target is at the end. I mean, even if the indexes are at the end that we could get, I think we'll always get, the difference. We'll be right back. All right, I am back. So yeah, we're on planning. Let me catch my breath. Hold on. I think I'm fine now. All right, so yeah, initialize the hash map. We can use that hash map to kind of like store the number as a value, as a key, and then the value as the index. I mean, the index is a value. So we can just go through the list of nums just iteratively. So iter through nums. So for I in range, all the way up to the length of nums. Is it nums that we're given? Yes, we're given nums. We can just, this makes me feel uncomfortable. Okay. Um, iterate through nums. We can just subtract. Do subtraction operation. So we can say that um, temp is equal to target minus num.I, right? And then we can say put temp into, I'm just gonna name it difference, so this makes sense. So put diff into hash. So hash map at diff is equal to um, is equal to no, I don't think we put a difference in there. Diff, yeah, and then we got to check if the difference is in the hash map actually. So if diff in hash map, and then cool. Cool. Then if difference in if it is in hash map, then we um we return um I, and then I and and hash map diff, which contains the value pair. I mean the value. I mean the index value. No, the index. Yeah, the index. Um, but if it's not, then that's cool. But then if that's not the case, then we're just going to just put nums into the hash map. So hash map at nums is equal to I. That I is equal to I. And then you can keep iterating. So in this case, let's say we want to get 7, right? So first off, we do 1 minus 7, that's 6. That's not in hash map, so we do 7 minus 2. That is 7 minus 2. That's 5. 5 is not in hash map, but we put 2 in there at index 1. Then 7 minus 3, 4, 5, 6, 7, that's 4. 4 is not in the hash map, we put 3 in there. Then we do 4. So 4 is not in, so we do 7 minus 4, that's 3. 3 is in the hash map, so if we actually return, um, 0, 1, 2, we actually return 3, 2. So that's interesting. So yeah, this does work. It seems like it works. So let's just kind of do that. Let's copy paste my plan into code. All right, so we're gonna follow the plan. Okay, so first off, we initialize a hash map. So initial was hash map. So hash map is equal to an empty dictionary. And we got to iterate through nums. So for I in range all the way up to the length of nums. We're going to get the difference of target minus nums at I. So diff or d is equal to, I'm just gonna diff, I like that. Diff is equal to target minus nums at I. And then we're going to check if diff in hash map, and then if that's not, then that's fine. Or if it is, we're just going to return I and then hash map diff, which will return the index. But if that's not the case either, then well, that's fine. We're just going to put hash. We're going to put nums at I in the hash map. It's equal to I. And then this should run. The logic makes sense. Everything looks like it works fine. Yeah. There's always one solution, so it should work. Okay, submit. And it works. Woohoo, very cool swag. Very cool swag. Alright, so we can also do this like O of n squared, but we're not doing it in that way because we are cool. So that's pretty much it. O of n time, O of n space. Because O of n time because we iterate through the list once, and O of n space because we use a hash map and we input, no, and then we store every number in the hash map as we go through. So yeah.